In this video, we're going to solve trig equations that have more than one trig function, but the same angle. Now, by more than one trig function, what I mean is it might have sine and cos, or tan and sec, or whatever. Now, your main strategy is that you want to use your identities to adjust it so that there's only one type of trig function in it. Now, there's lots of different ways that you can do this. So, as long as you're aware of that, don't be stuck wondering which way to go. Just start on something. And if it's a different method than the person beside you, as long as you've both got the same answer and you can explain how you got it, you're fine. So here, we've got an example where we're being asked to do it two different ways. Now, the reason we're being asked to do it two different ways is so that we can come up with a little bit of a note of caution about this second method. So we're going to solve 2 tan theta equals sec theta between 0 and 360 degrees, so that tells us straight away we're working in degrees. And we're going to start by doing it by using ratio identities. Now, what are ratio identities? Well, they're just those simple ones. For example, what is sec theta? It's 1 over cos theta. Can we express tan theta any other way? Well, it's 1 over cot theta, or we could say it's sine theta over cos theta. Which one are we going to pick? Well, if this is 1 over cos theta, and this is sine theta over cos theta, I'm going to pick that because that way I've got both of them over cos theta and they can talk to each other. So every time you're looking for variety, look for ways that they can communicate and have common ground. So I'm going to start on part A by saying this is the same as 2 sine theta over cos theta, and that's equal to 1 over cos theta. Now, if they've both been over cos theta, we can multiply both sides by cos theta and pretty well just get rid of that. And so now, dividing both sides by 2, I can see that sine theta is equal to 1/2. Now that's a familiar one to me. I know that the sine of 30 degrees equals 1/2. So theta could be 30 degrees. That's my first quadrant answer. But I know that sine of an angle is also positive in the first and the second quadrant. So I need the second quadrant answer, which will be 180 degrees minus 30, and I get 150. Okay, now let's use the second part here. Part B, I'll work over on the side here to give myself some more space. Squaring both sides. Why would we do this? Well, perhaps you're looking at tan and sec and you're thinking, oh, there's a Pythagorean identity that uses those. Your thinking over on the side might be to say, hold on a minute, I know how these are related, because in your question you might not be told a clue of how to start. So you might say, hey, here's something I know. Sine squared theta plus cos squared theta equals 1. That's on your formula sheet, and you probably remember that one. So to generate the one that's got tan squared in it, I can divide everything here by either sine squared theta or cos squared theta. Let's divide by cos squared theta. That'll give us tan squared theta plus 1, because dividing by cos squared theta, I get that, equals sec squared theta. Now maybe this is the one that's jumped into your head. Either you memorize it or you've generated it yourself. And now you might say, hey, I've got tan and sec, I can use this. Well, not a bad idea, but a word of caution. We'll see why in a minute. Now, if we square both sides, we know we need to do that so that we've got stuff squared. These things don't work if they're not squared. So squaring 2 tan theta, remember that if we have two things multiplied together and we square it, we need to square both things. Okay, there's that little rule. So that means we need to square the 2 and we need to square the tan theta. So we're going to get this, and then squaring this side is much more straightforward. We can just write it like that. Now, if you're going to use this in here, to me it makes sense to just swap out sec squared theta for what it's equal to. So we can take that whole right-hand side and we can write down this, tan squared theta plus 1. Now we can say we've got 4 tan squared thetas here and only one of them there. We can subtract one of them from both sides and say 3 tan squared theta equals 1. So tan squared theta must be a third. Now, remembering what this means, it means that the tan of theta all squared. And if it helps you to write it like that, feel free, it's not wrong. All of the something squared is a third. So if we want to find what tan theta is, it makes sense it needs to be plus or minus the square root of 1 on 3. Or we could just write that as 1 over the square root of 3. Okay, now this is a familiar one to me because I know that the tan of 30 degrees is equal to 1 over root 3. But if I've got the plus and the minus here, because squaring either of these would give me this situation, then I need all 4 quadrant answers. And so it's very tempting to say, all right, I need 30 degrees, but I also need the 2nd quadrant answer, and the 3rd quadrant answer, and the 4th quadrant answer. And I'm tempted to stop there. Now, have a look at my 2 solutions. This one was really straightforward, it was quick, and it was easy to do, and these seem to be the answers. This one's given me some extra solutions. Now, how can we tell whether these red herring answers turned out to be real answers or not? We didn't get them over here, we did get them here. It's tempting to sub them back into your equation to check it makes it true, but be careful that you don't sub them back in here, because if you sub them into this one, they will come out looking true. We need to sub them all the way back into our question. And I think you'll find that when you do 2 lots of the tan of 210, you do not get the same thing as 1 over the cos of 210. I can tell straight away because 1 over the cos of 210, that's in the 3rd quadrant. That's going to be a negative answer here. Whereas the tan of 210, 3rd quadrant, that's positive. Straight away I've got a positive answer. It's not going to equal a negative answer. So huge word of caution here. I recommend we take a red pen or a highlighter or something like that and we say, warning, always take care when squaring both sides of an equation. And the reason that we need to take care is because it can introduce potential answers that are not actual solutions. So let's write that down, potential extra solutions that are not correct.